So, I want to introduce you to Bob. This is Bob. Bob, say hello to the audience. Oh no, wrong button. Say hello again. No, he won't. Wrong button, that one? Yeah. Okay, thanks. So again, Bob, say hello. No, it works. Thanks a lot. So this is Bob, and Bob is a developer, and he wants to release his software tomorrow. And he's everything set up so far. It's only one little tiny bug that's remaining in the software yet that he wants to fix. So obviously, in order to fix the bug, he needs to change some code. And because he knows his stuff, it shouldn't be a big problem, right? Because he's a seasoned developer, he won't, break anything or something. So it shouldn't be a problem. But because the protocol asks for it, he still is requested to test his software. And he does this manually. And, it's a burden because there won't be any change really, but, oh, damn, okay. So he changed something that he didn't want to. He broke some functionality. He introduced a regression. So the cycle starts all over again. Because he wants to fix that bug that he introduced, he needs to change some code. And in order to, validate the change, he again has to test it. Although, there shouldn't be a side effect. Nothing should change, really. But, as it is in software development, there are unforeseen consequences to every change you make. And so, as time goes by, he's in this vicious circle of testing and changing and testing again. And at some point, he could have automated the tests. And he has automated some of the tests, actually, but the problem is, because of his changes, the tests broke. So he needs to maintain them, but because he wants to have his release done, he says, okay, I'm going to fix the test automation after the release, and just deactivate the test and fall back to manual testing, which maybe is not such a good idea. So he has to test manually, and it's very exhausting and cumbersome, and he gets tired and he starts missing things. He's not testing very good anymore. And at 11 o'clock in the evening, he decides, okay, scrap the whole thing. I'm going set back to the version I had and release with a tiny little bug that is still in there and fix everything tomorrow. At which point, he realizes that his version control system is broke. Now, this is a point where he starts to panic. Now, because his version control system is broke, the only thing that is left that he can do is continue and change and fix and change and fix and test. So eventually, after working through the night, at 8 o'clock in the morning, he is able to release a software that is not fully tested, contains some known bugs, and is still not good. So obviously that never happened. That's an urban legend. Okay, it never happened to me and never to anyone I know. Guess nobody of you neither knows someone who experienced something like this. This is what we don't want, right? This is the worst case scenario, and this happens if you don't have automated tests. So, short little survey. Who of you has ever tested software manually? Okay, great. Almost all of you. And who has ever tested regression? Regression tested software means something tested again that already worked at some point in time. Okay, and who liked it? Gotcha. Okay. And the question here really is, why didn't you automate regression testing, right? You should test new functionality. So the talk we heard before, if you want to exploratory test something new, but if you already tested it once, you should automate it, right? That's the ideal scenario. And the question is, why don't we do it? And the answer is this graph. Because when you automate tests, you have to put in a lot of effort for the automation. You have to set up your test environment, your test tool, you have to record the tests, you have to, create the whole thing, and you have to maintain it. So in order to have the tests stay in place and stay working, you have to maintain them, which is a lot of effort. So the effort that you save over time is less than the effort that you have to put in at once in the beginning. So as a rule of thumb, you shouldn't automate if you have less than 5 releases, because then the effort of automation is higher than the gains that you gain from it. And additional to that, you have another problem. The more you automate the tests, obviously the less risk there is that you will miss a bug, but also the maintenance goes up and way up. So there is a sweet spot in there. There is some percentage of tests that make sense to automate, and you don't want to automate every corner case, because that's not helpful and it costs a lot of maintenance effort. And currently there are between 20 and 30% of all UI tests automated. Everything else is done manually, on average in industry. So the problem is you have high testing effort and high test automation effort. And now we want to solve that for you. How can we do that? How can we have tests created automatically? Automated tests automatically. Well, there's the Infinite-Monkey-Theorem. If a monkey hits random typewriter keys, eventually, after like eternity, he will type the complete works of William Shakespeare. And if you replace the typewriter with a laptop or with a computer, then the monkey is doing your testing. That's the basic idea. And I brought you a monkey. So this is a fully functional monkey. It works. You can copy and paste that code and execute it, and it works. And with that you can test every application. Okay. You can test your 3D action shooter as well as Eclipse or whatever you like. It just works out of the box, but it's very stupid. So the thing it does essentially is do I have a pointer? You click on a random X and Y coordinate on the screen and input some random data on the keyboard. And so here I have a short demo testing a website, and as you can see, the mouse pointer moves frantically and tests the website, and this is very good because it works out of the box with any website. But the problem is the monkey is not very intelligent. If he clicks, for instance, on a link leaving your website, then he tests the internet, which is kind of not so sensible. And also, if he finds a bug, the bug will show up on the server, so you will need to scroll through the logs. And if you do so, the monkey won't be able to tell you what he did. So these tests are in a sense not repeatable. So you can't ask the monkey on which link did you click or which text did you enter in which field or something like that. And if you don't execute it on a website, but say on a local desktop application, and the desktop application crashes, what the monkey is supposed to do, then he continues, and then he tests your Windows. When he connects to the server and starts deleting files from your company share, this is where it stops being funny. So make sure to sandbox this guy. And as you saw, we just left the website that we wanted to test and went somewhere else. So this is a dumb monkey. This is not very helpful. I mean, it's good, it's cheap, and you can set it up and let it run 24 hours, 7 days a week. It's cheap to set up, but it's not very good. It's dumb, and we want something intelligent, something like this. And the question is, how do you make this intelligent? Well, you add context. For instance, you can now, so the monkey before could test any application. Now we only test websites, right? With this again is working code. You can use this and execute it, and it works out of the box. And it tests only websites. But now it's easy to extend. Now, because you know where you are, you can ask, am I still on the same page, on the same site? For instance, if I have a login page, you can tell the monkey, okay, here are valid credentials. Please log in and then start testing. Or you can tell the monkey, don't press the print button, it costs too much paper. or don't press the email button, it's just spam, something like that, or don't press the delete database button, right? So you can extend the monkey and train him to do what you want or not do what you don't want. And it's more or less, it's easy to do so. And this is the reason why there are already some implementations of this. So open source products for websites. There's Gremlins.js, which tests the website. Netflix Chaos Monkey, if you have a SOA architecture, and the UI application Exerciser Monkey, if you have an app. Or, as you just heard before, you can use the app crawler if you have an app, something like that. So it's quick and easy to implement, and it finds bugs. Okay, it's cheap and it finds bugs. Run this for a couple of hours on your application, and your application will crash. I guarantee it. But the question is, are these bugs relevant? Are these just corner cases that no one ever encounters? And the monkey is, as I said, not intelligent and trainable in a sense that I come to, and you need to sandbox the whole thing, right? Because I said it's an intelligent monkey, that's what it's called, but it's not intelligent by itself. You have to design the intelligence into it, right? It's not artificially intelligent. But we'll come to that later. How can you train the monkey? For instance, if you have a complex use case, okay, you have a web shop, and the user needs to log on and fill in some forms, place an order, then you log off, you log on with an administrator and mark the order as shipped, and then you log off with the user. Again, they have a complex use case, and you want to test it. Well, the monkey won't come up with this test case, at least not in 2 weeks until the next release. So how do you have the monkey do this for you? Well, there's an analogy. Right now, there's many talk about self-driving cars. And if you want to have a car drive by its own and have it visually analyze the scenery, then the car needs to find its lane, it needs to find obstacles, it needs to find all the traffic signs, and it needs to find out which traffic signs are valid for the current lane, and it needs to find all the traffic lights, and needs to find out which of 6 lights is valid for the current lane at where it is. And all of this in real time, because it doesn't help you if the car says, oh, there was a pedestrian 200 meters before, right? So you need to have this data or the answer in real time. And frankly, we can't do this. So right now, software and hardware is not capable enough to do this in real time. But still, Google has their cars drive around, right? So how do they do it? Well, if you can't solve a problem, if it's too big, solve a different one. Try to find one that's smaller. And that's what the Google guys did. They photographed everything, terabytes of data, and analyzed it offline. Okay, so they had all the time in the world, right? If it would have taken a year longer, we would have the self-driving car a year later, and throw as much computing power on it as they have. Okay, they throw the whole Google Cloud on it to do it offline, and analyze all the things out of the data, and then combine it with localization information. So then you get a whole different problem, because now you know on which lane you are. You know how fast you can go, and you know in which directions you can turn or not. And now you only have to find the obstacles, and you already know that there is a traffic light, and you know where it roughly should be in the picture. You only need to find out whether it's red, green, or blue. And this is what you can do today. And now we do the same with the monkey. So if the monkey can't find out that on his own, then we train him, right? Capture and replay. It's been around for 20 years. So you capture a test, and the longer that use case is, and the more complex it is, the more special cases it includes, right? What happens if I push the back button? What happens if I enter -1 as a quantity? What happens if I enter a shipping date next year? What happens if I enter, all that stuff that you all want to test, right? You want to test all of those corner cases, and the monkey does this for you. So you record one test, the ideal case, the happy path, and the monkey does all the other stuff. So now it's trainable, and based on realistic use cases, But the question is, what about coverage, right? So are those tests that he generates even relevant? Are they even something that make a difference in the code, so to say? Well, it's already pretty intelligent, but not on its own. It's not an artificially intelligent monkey yet. So how can we do that? How can we make the monkey even more intelligent? We can use a genetic algorithm, which is a tool of artificial intelligence. And it basically works like this. You put several searches in parallel, right? So a search is you try something out, you don't know what happens. It's exploratory testing. So the monkey executes the UI and tries to find what happens. And you measure the coverage. And you want to parallelize this. But you want to find good intermediate results, and you want to push these results, intermediate results, from one search to another, right? So if the monkey found something, a valuable state, for instance, he learned how to create a user, then you want other searches to reuse that state. And this is essentially a search that works like this, right? You spread the search into all directions of the search space, and then at some point you get a good result, and you use this result. And the thing is, the most important feat of a genetic algorithm is that it's able, what I just said, to exchange good candidates, right? So if, for instance, you have two tribes, and one tribe is is evolving and has good ears, and you have another tribe that's evolving and has good eyes, now these two can mate and have sex, and get offspring that has both good ears and good eyes. Now you know why sex is such a good thing. You wouldn't have known before, right? And you have to think about it. Mating is used by every higher level of living species. It doesn't matter whether it's a plant or an animal or a fungus or humans. Every higher evolved biological species uses mating, although this is expensive, right? You have to find your mate, you have to spend a lot of effort and a lot of energy, and still everybody is doing it because it essentially means you get a higher abstraction of the search. If you regard genetic algorithm as a search, then if you are a bacteria, all you can do, and you clone in order to evolve, all you can do is you have a mutation, which basically means that one of those guys, of the acids, gets switched. And this can be good or bad, but it's not very effective. If you have mating and you can exchange genes, then you can suddenly exchange a working functional block of genetic material, right? As I said, someone who has blue eyes can mate with someone with red hair, and they get someone with blue eyes and red hair, and this is very, very effective. So I want to show you how effective this is. As an example, I have the Towers of Hanoi. You probably know this math game. So you have the 3 slices that you can move around, and according to some certain rules. And if you have 6 slices, it becomes a lot more complicated, but still works basically the same. And with 6 slices, you have 2 to the power of 63 possible solutions. Right? So you have 63 steps that you have to the slices to move around, and you have 2 to the power of 63 possible solutions. Okay, who calculated what this is? No, it's 9,200,000,000 something. This number is so high that we even can't grasp what it means. So if you translate it into a time, you can say, okay, I try 1,000 solutions per second. Then it takes me almost 300 million years to try every possible solution to find the perfect one. And because maybe you're lucky and the first try is already the right solution, or you're unlucky and it's the last one, so on average you need half the time, right? If you try every possible solution, you need roughly 150 years. And now the genetic algorithm is so efficient that if you apply genetic algorithm to this problem, with the same measurement, you only need 66 seconds. This is why we all have sex. And this is essentially how you can make the monkey intelligent. You can take all those test cases that you just recorded with a record and capture and replay tool, and have those test cases be the genetic material that the genetic algorithm works with. And so you get all those use case tests that change the corner cases or whatever, and you optimize it for coverage, for code coverage. So yeah, as I said, now realistic use cases, and it's very effective. So this is essentially how we make the monkey intelligent. But so far it's only crash testing, right? So far it's only looking how it can crash your application. But maybe that's not, not interesting. I mean, maybe there aren't that many crashes, but in the beginning we talked about functional testing, regression testing, right? So how do we put artificial intelligence into functional regression testing? Well, some people will tell you that it won't work. So, for instance, the CPO of Tricentis thinks AI in test automation is a hype. Or the CTO of Test Plant says so far he's not seen anyone doing it in a useful way. Well, he should have been here, because then he would know. The question is the reason why all those guys think that AI is not working in testing essentially is the question: which bugs can the monkey find, right? So can you find the bug in the picture? Okay, so this thing essentially is a bug, and it's hard to spot. And if I ask, for instance, if I ask you, okay, now I give you the software, and I ask you, is this value that I marked, is it correct? Yes. Okay, so he says yes. Who thinks otherwise? So the thing is, how should you know, right? Without knowing which software, what it does, what it calculates, which parameters it takes, and what it depends on, how should you, in heaven, know what the correct value is, right? And this is called the oracle problem. So this is the problem that the artificial intelligence is not able to spot bugs, because he executes the software and he doesn't know whether some value that's shown on the screen is correct or not. So he's useless as a tester, right? Because what use is a tester that doesn't find any bugs? So, and this is a reason why AI doesn't work in testing. Though, I asked before, when is a bug a bug? Well, when it's not a feature. You see, this bug is not a bug, it's a feature. And because without specification, there are no bugs, only surprises. So the question is, why do we test? Well, after the implementation, if we have a new functionality, a new feature, obviously we want to find bugs, right? If you have, like with a calculator example, if you have a calculator that says 1 and 1 is 3, obviously that's wrong. And if it says 2 and 2 is 4, obviously that's right. Okay, this is what you expect. This is testing, as we do it, functional testing. But if you have an application that's already there, right, and it has like 100 screens, and you only want to change one screen, like Bob in the beginning, right? One tiny bug, a little change of a slight functionality. Then you want that to test manually. That's not the effort. That's not the problem. Testing this single screen is not the problem. But you need to test all the other 99 screens as well, just to make sure that there's no unwanted side effect. And this is where the problem is, right? You have to test all those again, every time you make a change. So now the situation is different, because if you spot an error in one of the 99 screens that's been there already for years, you don't bother, right? I even had situations, so if you have a banking software that calculates whether you should buy a certain asset, the question is, and there was a mathematical error, and they fixed the error, and the bankers wanted it to be put back in because now the recommendations were wrong. Thanks. So after a change is differently. If there is a bug that's been in the software for years, it's the right thing, right? If your software calculates 1 and 1 to be 3 and your customer is accustomed to it and uses that software for years, he doesn't want that to change randomly. Now 5 is the wrong answer and 3 the correct one. Mathematically, they are both equally wrong, right? But the one is the one that the first one is the thing that the customer is used to, and the second one is not. So the second one is wrong and the first one is correct by any standard, right? So now we don't want to find the bug. We don't want to, with the regression testing, we don't want to find whether 3 is correct or not. We only want to say whether it's the same. So regression testing essentially is not testing. Because with testing you want to find bugs, but with regression testing you don't care about the bugs. Regression testing is not testing. Let me repeat that. Regression testing essentially is version control. Because with regression testing you want to find the differences. It doesn't matter whether it's right or wrong, you want to find the differences. So this is a version control, or this is a diff for a code. If you program, it's on the code level, you get a diff like that. And you want that for the UI. You want to have something like this, right? You want to say, okay, before it's been that and now it's that, right? And you want that. So in a way, this is the Oracle problem, okay? We removed the Oracle problem from testing. Now we can test without Oracle problem. And now afterwards, if there is a change, you as a human have to review the change, solve the Oracle problem, and tell the computer whether the change is correct or not. And this is essentially what we do. And the nice thing is, now suddenly, managing or maintaining those tests becomes easy, because now you can just say, yes, I wanted this. I changed this screen. I want this new value to be the correct one, and the next time you test, please make sure that this new value is there. So now I maintained the test like with a commit with a version control system. As easy as that. And the monkey can do that for you. The monkey can't solve the Oracle problem. The monkey can tell you whether there are functional bugs in your software, but he can record everything that your software does, and if this changes, he can ask you whether the change is correct. And you can confirm if it's a wanted change or you just found a bug, you found a regression. The database value is not loaded anymore, something like this. There's a change and you can review it. So now we trained the monkey to do functional testing. We didn't solve the Oracle problem, we moved the Oracle problem to somewhere else. We removed it from regression testing. And we created, in a sense, a version control system for the UI, for the graphical user interface. So, I think I'm early. This is a summary. Now I want to show you some more examples of known bugs. So we are a young startup in Germany, and we have GitHub. So much of what you just saw will be available as open source product in like 2 months or something. Not the monkey, but the difference testing will be available as open source. And we are also doing Kickstarter campaigns in the middle of this year for web and mobile. So we want to apply this technique. We have it solved for Swing. We have a working product for Swing. And we want this to have as open source, the difference testing for web and the difference testing for mobile as an open source tool. And we want you to contribute and help us, create this. And if you're interested, please go to our website, follow us on Twitter, whatever. So, thanks.
Hi, thank you for the talk. I have a question. You say that we now have ability to push the Oracle problem from the monkey testing to the human. But what are we going to do if the amount of Oracle problems for one regression is so huge that it takes to human about an hours?
Well, essentially, You can always fall back to manual testing, right? So if you don't have working test automation, if you have so many changes, then all, like Selenium or every other test automation will also break. It will fail because so you can't rely on it, right? So if you have that much changes, then you fall back to manual testing. But if you have manually tested once, then you can take a snapshot basically of that version and test from there on again.
No, I mean, it's obviously that this approach are better than raw manual testing because we automate something. But what I'm talking about is there any approach to fight against the amount of Oracle problems? Like if you already have a lot of tests and they are show the regressions and somebody need to see all of them and to decide is it right or not. It can be a huge amount of job especially if you have a lot of screens or a lot of UI.
Well, what we basically do is that we summarize the changes. So if the same change applies to one component in different tests, you need to accept it only once. So if for instance, the login button changed, you can say maintain, and then all of the instances in all of the tests of all of the login buttons will be accepted as well. So you don't need to check every single instance. Only if the values differ. If you have a field that comes from a database and it shows a different value every time, then you need to review the different value. Is that your question, essentially?
Yeah, approximately, but there is still no answer. I mean, yeah, okay.
So yeah, essentially the Oracle problem is unsolved and unsolved by us. So there's just so much you can do.
Okay, thank you.
1, 2, 3. Hi. Do you have gray area configuration? Like this database could return a random value or like hash functions of some kind, some personalized value. So how do you configure gray areas?
So basically, like with any version control system, like with Git, you have your git ignore. Or with SVN, you have the SVN ignore, so you have a central configuration what is ignored, and we do the same. So essentially, you can say, okay, this. So here, do I have it on
like this kind of change will be ignored from now on.
Right. So here, essentially, you have a date and time, and obviously this changes. Too bad. So you can just tell the version tell the system to constantly ignore this, so it doesn't pop up as a difference. But on the other hand, you should have a more or less stable testing environment, right? Today with Docker and containerization and stuff, it shouldn't be too hard, but you need to have the data.
Most of the times you just run these cases simultaneously, and they use the same data. But will these gray areas remain on their places to the next release?
Yes. Well, you can move them around if you need to, but if you ignored something, it stays ignored until you unignore it, so to say. Yeah. So, I don't know your specific use case, but maybe you can go into details later. But
Hi. I really like this approach, but let's try to implement it to the real world. Let's say I have Microsoft Paint application everyone knows. How much effort will it take to implement this, such kind of testing?
For Microsoft what?
Paint.
Paint. All right. So Paint so there are systems for which it works better and systems for which it doesn't work as good. So it works best for systems that have structured input. So if you have a typical form to fill out, like or with like most B2B applications where you maintain data, you have those crude applications, right, where you create, update, delete data. it works best. If you have like a 3D action shooter where everything moves at once and everything, you know, this is hard to test with Monkey. So there are systems for which it works better and systems for which it works not as good. And Paint is an example of a system where it doesn't work as
Okay, can you tell about a good example to implement this and how much actually effort in human time it will take or money to implement this approach? How hard is to apply this?
So, well, it depends on how much you want to put in. The monkey that I showed, the first one, the stupid monkey, it works with Paint. So you can take it and let it run in Paint and see if Paint crashes. So it already works, so to say. And you want, depending on how much effort you want to put in, you can make it more complex. You can, you know.
Okay, do you have any working examples of implementing this?
So we implement it as a product, and for Java Swing, it works if you have it works basically out of the box with our product that is going to be open source in 2 to 3 months. The difference testing part of it. So is that answer to your question?
Somewhat.
Okay. Maybe you can come later to the question answer.
Крайний вопрос.
Hi. Could you please tell if this approach is applicable to API testing?
Yes. Well, not exactly. This is an instance of fuzz testing. And with API testing, you would take fuzz testing. So, for instance, there's the tool Mozilla. It's too bad it's not a product. They use it internally. They have a tool where they take all of the JavaScript that they know about, like millions of lines of JavaScript code, and they put it together randomly, so it's still valid JavaScript, and execute it inside the Mozilla and see whether Mozilla crashes, for instance. So if you have, for instance, an XML interface, API interface, you can. Oh, sorry. Are you talking about programming interface or?
I'm talking about, for example, REST API.
Yes, that's what I meant. With the REST API, for instance, you can generate more or less random XML that's still valid XML and see whether your REST API or REST service crashes.
Oh, thank you.
Welcome.